Hey, hello guys. So today let's learn about open close principle. Hope you watched my previous video on the single responsibility principle. Now let's go through the open close principle. So formal definition is let's go through the mistake first. Most of this most of the confusing topic is open close principle. Almost everyone confuses in this, so let's go slowly. Suppose we are having a database which has the payment system, like, or an application which has the payment system. Just let me create a file called open closed principle dot principle dot py python file, then have this code. Let me explain this code first. Suppose we are building a payment system. Okay, so if you see here, we have UPI payment method, and the UPI payment method prints this thing, and whatever the amount we enter, and UPI transaction finished. And credit card, similarly credit card, net banking, etc. In future, when my boss comes to me and says that add a new Google Pay method. In that case, I need to do this thing, right? Like, add a new LF method and add Google Pay here. Then Google Pay transaction is completed. So whenever a new method comes up, like a new payment method comes up, I need to add LF, etc. So this is quite a bit constantly editing the old working code. Like, if I add a new payment method which has some bugs, that will, in some way or one way, it might affect all the existing working methods, right? This is not quite efficient, so it might eventually introduce some bugs. So what OCP says is, software should open for extension but closed for modification. Like, I should be able to easily add a new payment method without touching my old existing code. So this is the principle which OCP states. Okay, so instead of touching the old code, don't keep changing the old code, instead add new code. Now if I want to change this is a bad example actually. Let me change this bad example to a good example based upon the principle stated by OCP. So now what I'll do is, let me keep this thing as it is, and let me give this a name called bad example. Well, and comment it out. Now also comment these things. If you run, actually, if you run this program, right, you can see this works. This program actually works. But the issue here is, whenever we add new payment, we are not supposed to touch the old existing payment methods. So this is the principle which states the OCP. So now let's make this to a good code, good example. Let me comment out this and add a good example. I'm a bit slow at typing. If you don't mind, you can watch it on the 1.25x speed. Okay, so now let's create a class payment method. In this, let's create an abstract method. what abstract method means is, whatever this, it's like a global class. What it does is, whatever the method defines here, it should be implemented by all the children which uses this class. Okay, let me import this as well. Import abc from abc, import abc and abstract class, abstract method. Yeah, so now let's copy this and add an abstract method here. And usually whatever the payment gateway we use, we usually have a pay method, right? So now pay, it's defined inside the class, so self and amount which will be in integer. If any of the class is not implementing this payment method, so we can raise an error, not implementation error. So, and we can notify the user that payment implementation must be done. Now this is one class. Now what I did is, I created a global pay method. Now whatever the methods I have, like UPI, credit card, net banking, Google Pay, etc., I'll create each individual class for them, like class UPI method. What I'll have, since my UPI method is inherited from payment, I need to surely implement the pay method. In this I'll be having self and amount which I enter, which will be in the integer format. Now what I'll be returning, or else let me print this thing, a string amount paid via UPI payment is, and let me define amount here, amount. So similarly, new method for debit card, debit card is, then similarly for credit card, done, right? So now we created individual classes for the payment methods and a global payment method which is inherited by each individual payment methods. Done. Now let's create a class which connect these things, a payment method and the payment way, like payment gateway, like class payment processor. So here what we'll do is def creating a function process payment. Let me keep this process payment, and we'll be having self, the payment method which will be of type payment method, and amount. which will be of type int. Now payment method dot pay, and I'll be passing directly method amount, whatever the amount I'll be receiving from here, I'll be passing this, and I'll additionally a payment method. So now if you see here, for suppose in future I want to add a Google Pay similar to this. Now in the earlier bad example case, I was touching the already existing code and I was changing the old code. So now if I want to add a new payment, just create a class, that's it. This payment processor automatically calls that method, and it implements the pay method inside which is defined inside that. So now let's test this. Let me create an object for debit and debit card method, and credit, and a create and credit card method. Done. Now payment process. Now I created an object for debit card and credit card classes. Now let me create an object for payment process. Man, what's happening? Now we created two methods. Well, like we created two objects, one for credit and debit, and we created an object for payment processing. Now we need to add object, like we need to specify method and amount so that the payment happens. Now let's go here and see payment dot process. Inside payment process I have process method, right? So in this I'll be passing debit card and amount as 500. So method, which is nothing but 500, and amount is method which is nothing but debit method, and amount is 500. So now 500 amount comes here and goes to the pay method, and pay method, whatever the pay method I am using, like debit card, it goes to the debit card method, and we'll be getting debit card amount paid via debit card, and the amount is this. Let's test it, this example. See, you see here, right? Now let me give a credit card. See, credit card. So in this way, what we are doing is we are not changing the already existing code, like we are not editing the old code but we are easily able to add the new methods and new classes easily. So the OCP principle is justified. Thank you. Hope you understand this OCP principle. Let me give a formal definition for this as well. What was the definition? Yeah, so the formal definition of OCP is software entities like classes, modules, functions should be open for extension but closed for modification. True, right? These are open, classes are open, classes, modules and functions are open for extension, but closed for modification. The earlier implemented classes, they are closed for modification. This statement is justified. This is the definition and the problem and good good example and backed example solution for the OCP principle. Thank you. Let's learn about L, which stands for Liskov substitution principle, in the next video.